Hi, my name is Patrick, and today we're going to talk about the importance of main venting in steam heat. So here we have three different scenarios. We're going to talk about all separately. Alright, so here's a typical scenario. We have a boiler with some water inside and it starts producing steam, and you have two main pipes, one short one long one, and at the end of those pipes you have main vents of equal sizes that means equal openings. So obviously after, let's say, 1 minute of the boiler working and heating up, you have more or less the same equal amount of steam in one main pipe and the other main pipe. Nothing unusual here. And then we are thinking like, all right, listen, how could I steer more steam going to this direction than this direction? And it's very easy. You basically add more venting to this side. So let's see what happens. Once again, similar scenario. We have a boiler, two main pipes, but something interesting happens. When you added two vents to this side, which means basically double the venting rate of this side, is that if you notice, pretty much all the steam at the beginning of the steam cycle, instead of equally spreading to both of those vents, went in this direction. So why, you might ask yourself why that is, and the reason for this is because ultimately steam is quite lazy, and it wants to do as low work as possible. So as it's pushing out the air through the main vent on two sides, it tries to do the bigger the opening obviously implies that it's going to be easier to push out the air on this where we have bigger opening than when we have a smaller opening, and because of that this pipe fills up with steam while this one just remains quite empty. Now of course then at some point the steam hits those valves, then they closed, they end up being closed, so because of that the steam cannot fill up it cannot keep on pushing through this main pipe, and the boiler keeps on producing steam. So all of a sudden that steam has no other way than go in this direction, and then that's when that main starts filling up. So let's see what would happen. Let's say if we had decided to add two vents to the long main and the short main, and here we have our third scenario. So in this scenario, as expected, we're going back to our original scenario, which means when you have the equal amount of venting on both sides, the equal amount of steam goes in both sides. So this is kind of like all relative. I put that this is the amount of steam you will get with 1 minute. This is the amount of steam we get in the 30 seconds. That's not exactly true, because there's only, at least at the beginning of the boiler operation, there's limited amount of steam happening. So because of that, you basically would still get the same equal distribution if you have the same venting on both sides, because it takes the same amount of force, the same amount of work it takes for the steam to go either pipe, to push out the air out. So now let's see how it helps us in a practical scenario. That is, if we know that the steam will always want to go where there's the least amount of resistance, which means the extra venting than less venting, then let's create some real world scenarios and see what happens. So here we have our boiler, our two mains, one long one short one. Then let's say add a radiator. First of all, let's just add one main vent here, another main vent here, and let's see, add one radiator here, and then maybe another radiator here, and then why not another radiator here as well. So okay, so based on our original description, based on our original diagram, if the steam starts going in the same equal speeds or equal amount to both of those mains, that means this radiator is going to be hit with some steam as well and starts heating up, and this is going to be hit with some steam as well and will start heating up as well. Alright, so great, those two radiators starts heating up. Now what happens, let's say, if we have a thermostat set somewhere here? Yeah, so because of that, this thermostat starts feeling the heat from this radiator, and then all of a sudden my end call for heat from the boiler. So because of that, let's say, okay, the radiator heats up, no more heat is needed because the thermostat is satisfied. So what happens with this radiator? And again, remember, this is obviously by definition slightly exaggerated drawing to kind of get basic principles of operation. Then this radiator stays cool or close to be cool. So let's see what happens if we end up going our original scenario, or rather our second scenario where we have two vents. So set aside so we can create a similar scenario, but now we have as previously one vent here, and here we have two vents. And then the same scenario in terms of radiators, one radiator here, one radiator here, and then one radiator here. As we predict from this scenario, this main is going to fill up way quicker. Oh yeah, and we forget also to add the thermostat here. So this main fills up really quickly, and with that this radiator fills up, and also this radiator fills up. And only when those two when this leg is satisfied, then the steam boiler finally fills up this leg with heat, with steam, and then this radiator fills up. The thermostat gets satisfied, the boiler shuts down, and everybody's happy because all the radiators heat up evenly. Now, once again, this is simplified because it doesn't work like that in real life, or it doesn't work so cleanly like that. That is, by the time this main steam hits those mains, the boiler probably produces quite a lot of more steam than when it started out with. So because of that, it probably has ability to keep on pushing the steam in this direction as well, so that this leg might get filled up with steam even before those radiator gets totally filled up. But again, because there's tons of steam produced by then this radiator, because there's only so far the steam cannot go anywhere else other than to its vents on those two radiators, and this one as well. So this fills up with steam quite quickly. This fills up with steam relatively quickly as well, and this might be filling up with steam more or less at the same time as this radiator is. So again, by controlling the sizes of those vents as well, because remember, main vents usually are quite big vents. So let's say that's why they put it here as the quite big circles. That means they release quite a lot of they allow you to release quite a lot of air from the system. Vents on the radiators by definition are much smaller, so because of that, the steam will, as always, want to go to the place of least resistance. So when the tiny little opening is here, so that steam keeps on going, might want to go to some other place, like let's say this one. Instead of trying to be released by this opening, want to go to this opening right here. However, because there's already plenty of steam in the main, then what ends up happening is just the little bit of steam that still travels this direction will keep on going to the radiators. So in that sense, let's say, again, to use a real world scenario, so does work maybe like this. Yeah, I used to have in my own house this scenario at first. So I have actually quite a decent venting, as in two large vents at the ends of the mains on both legs, the short one and long one. But the long one had few, quite frankly, radiators at the end of it that were just they were always lukewarm. They were never heat up too well. And all I ended up doing is just going to this scenario where basically I had an extra vent under my long leg, and it already had quite a big vent. I think it has Gorton number 2, if I remember correctly, and I added one more, and that changes things dramatically. All of a sudden this leg got filled up before this started being even warm, and then all the radiators that before would stay quite cold started getting heat, and then this radiator started getting heat secondary, and that solved my problems of how to balance. So in other words, sometimes when we hear about the balancing the steam, we keep on talking about just kind of like, oh yeah, let me just increase, let's say, the venting here, and maybe let's make it triple dots here, and then maybe 2 dots here, or even now 1 dot here, and then maybe 2 dots here. And yes, that kind of can work if we're talking about the system that keeps on producing constant amount of steam. What ends up happening, much of the depending of course on the situation and the temperature outside, but much of the heating often happens on the kind of the early stages. Let's say when the boiler just starts producing the steam, and there's a limited amount of steam happening. So because of that, then main venting is very important, because then that little bit of steam just always wants to go on the path of least resistance, which is the mass, where there's the highest amount of venting. So again, as always, vent your mains as quickly as you can, and then your radiators, try to slow it down so that you don't get too much condensate coming out of the spitting out of your air vents. That's it. I hope that was helpful for somebody.